In this video, we're going to introduce the trig functions with their definitions using triangles, and then compute some at some special angles. So, to start, we want an angle in standard position, and we select a point on the terminal side. It doesn't matter where that point is. Now I'm going to do two different examples here. So I'm going to do an acute example. So an angle that's acute would look something like that. Okay, so here's our angle. But we could also have an obtuse angle. So that's bigger than 90 degrees. Okay, so maybe we want something like this. Okay, so then that may be our angle. So what we're going to do is select some point on the terminal side. Okay, so maybe here's my P, my point. I did it again. Okay, X, Y. Okay, or maybe here it is on this one. Okay, it doesn't matter where you select it. But then we're going to use this point to make a triangle. Okay, so we're a right triangle. So we're going to drop a side length down, okay, so that we get a right angle. So here, this is why I wanted to do an obtuse one. Okay, so we get a right triangle like this, but we're using what we call the reference angle. Okay, so that's this angle here. I'm going to call it theta 1. Okay, so we get a reference angle. So, because I have coordinates x, y for P, we know that this distance here is the x value, okay, and this distance here is the y value. Okay, similarly, for the obtuse one, okay, this is x, but it's going to be a negative x. Okay, and here's the y value. And then we have this, let's call it an r side. Okay, so that's the length from the origin to the point. Okay, so because I have a right triangle, we know Pythagoras identity holds. So the hypotenuse squared should be equal to the sum of the squares of the other sides. So that's going to be x squared plus y squared. Okay, so then we can solve for r if we want. It's going to be positive because it's a distance, so I just take the positive square root of x squared plus y squared to find r. Okay, now from our angle, or our reference angle, we have some special names for these sides. So like I already used this one, so the r side we call the hypotenuse. Okay, I'm going to use hype for short. Okay, the side that's across from the angle that we're interested in, that's going to be the opposite side. Okay, and the side that's next to the angle, that's not the hypotenuse, is the adjacent side. So I'm going to use ADJ or OPP. Okay, so similarly, this y is the opposite because it's across from the reference angle. Okay, the r is the hypotenuse, and the x here is still the adjacent side. So we can use this to define our trig functions. So you probably remember this acronym SOHCAHTOA. Okay, so what it stands for, so let me just write it here. Okay, so I sort of wrote it in groups of 3 because that's sort of how we use it. Okay, so S is for sine. Okay, so the sine value is the opposite side over the hypotenuse side. Okay, so that's how we compute the sine. And I've seen this recently instead of like this in high schools. So you might have seen it like this instead. So now it tells you it's the opposite over the hypotenuse. So you can sort of see the layers there. Ka, okay, so that is the cosine value, is the adjacent over the hypotenuse. Okay, and then the tan, or the tangent value, is the opposite over the adjacent. Okay, so that's how we define these trig values, so that's a way to remember it if you'd like. So for an angle theta with point x, y on the terminal side, okay, that's what we just had in standard position, and r the distance from the origin to the point, then we know that sine is the y over the r. Okay, so this is the opposite over the hypotenuse. Okay, the cosine is x over r, so that's the adjacent over the hypotenuse. Tangent is the y over the x, so that's the opposite over the adjacent. Now, this is assuming that x isn't 0. Okay, now r shouldn't be 0, but it's possible that, because you get to pick that point as far away from the origin as you want on the terminal side. Okay, so we don't want r equals 0 either. X might be 0. Okay, so for if you happen to land on the y, your terminal side is on the y-axis. Okay, so then in those cases tan is not defined. Now we could also write tan. So y over x is the same as y over r divided by x over r. Okay, the r's cancel out, I get y over x. So that's actually sine theta over cos theta. Okay, so you can, that's our first identity, trig identity. Okay, now cosecant, maybe I'm just going to write what these ones are. Okay, so that's what this one is. Cosecant is actually 1 over sine. So the way it's defined is r over y. Okay, so it's the hypotenuse over the opposite. Okay, but actually it's 1 over sine theta. Okay, so that's what you want to remember. Secant, okay, looks like that. So sec is r over x. Okay, so the hypotenuse over the adjacent. This is actually 1 over cosine theta. And the cotangent is 1 over tan theta. So it's going to be x over y. So it's the adjacent over the opposite. Okay, so it's 1 over tan theta, which you could also think of as cos theta over sine theta. Okay, so there's lots of different ways to think about that. Now, some people get confused with especially cosecant and secant. Cotan, because it has the tan in it, it maybe is easy to remember it's 1 over tan. For the other two, the way I always remember is the letters switch, right? So I have S for sine, C for cosine, and I have C for cosecant, S for secant. And notice that they go with the opposite letter. So cosecant goes with sine, and secant goes with cosine. Okay, so that's how I remember them. So that might be useful to you. Okay, let's do an example. So let's determine the trig functions for the angle in standard position in which the terminal side passes through this point. Okay, so we don't even need to know the angle. So let's draw a picture. Okay, so it tells me that the point is at -8 and 15. Okay, so that's where my P is. Okay, so now I could draw my angle. Okay, so there's the initial side. It should be in standard position. So the terminal side should go through this point. Okay, so this is the angle we're talking about. That's the theta. Here we're going to be using a reference angle because it's an obtuse angle. Okay, so we're going to have this side is 15. Okay, this side is -8. And then we need to find what r is. This is a right triangle. Okay, so I first want to find r. So r is going to be the square root of 15 squared plus -8 squared. Okay, that happens to be 17. if you compute that. So sine of theta is the opposite. So remember, this is our reference angle here. Okay, so the opposite is this 15, the adjacent is this -8, and the r, the 17, is our hypotenuse. Okay, so sine is the opposite over the hypotenuse, so it's going to be 15 over 17. Okay, cosine theta is the adjacent over the hypotenuse, so it's going to be -8 over 17. Okay, the tan theta value is the opposite over the adjacent, so it's going to be 15 over -8. Okay, and then we have all these extra trig functions. Okay, so cosecant theta is 1 over sine theta. So all you need to do is flip the value of sine theta. So instead of 15, maybe I'll just write that. So 1 over sine theta. Instead of 15 over 17, I have 17 over 15. Okay, secant theta is 1 over cos theta. So instead of -8 over 17, I have 17 over -8. And cotan theta is 1 over tan theta. So instead of 15 over -8, I have -8 over 15 for those values. So those would be the trig values for the angle that with terminal side that goes through that point. Now if we take point P, okay, so that's xy, to be on the terminal side as well as on the unit circle, okay, then r is 1. So our definitions get easier. Okay, so remember cosine used to be x over r. Now it's x over 1, so just x. Okay, so cosine is the x coordinate of our point, and sine used to be y over r, so it's now y over 1, or just y, so sine is the y coordinate of P. Okay, so then we can say some more things about cos and sine. So I'm going to draw you a picture. So what I mean, okay, so our angle's in standard position. Okay, so let's draw the angle first. Okay, so maybe it looks like this. Maybe that's our angle. Now we want it to be on the unit circle. So I draw the unit circle in here. It's not a great circle, but okay, it's the unit circle. So this is -1, 0, 0, -1. This one's going to be 1, 0, etc. Okay, so our point P is this point here. Okay, so because it's on the unit circle, okay, we know that this length is 1. Okay, so that means that this is actually cos theta sine theta for the coordinates. Okay, so this distance here is actually cos theta, and the height here is actually sine theta. Okay, now we also know that the unit circle has equation x squared plus y squared equals 1. So because our point is on the unit circle, it has to satisfy this equation. So since P is on the unit circle, we must have that cosine theta squared plus sine theta squared. So I'm just plugging in the x and the y values. That looks like a fraction. I don't want to do that. Okay, so this is the x value and this is the y value. So I'm plugging that into the equation. I should get 1. Okay, this is our first identity. So now when we square a trig function, we normally write the square here so we can save the brackets. Okay, so this is our first, or one of our first identities. It's one of the most important, the Pythagorean identity. So for any angle theta, we have that sine squared theta plus cos squared theta has to be equal to 1. Okay, if you're going to remember an identity, this is the one. Okay, so I'm just going to make a note here so we remember when I mean by sine squared theta or cos squared theta like that is actually sine theta all squared. Okay, so if it was sine theta squared like that, what it actually means is sine of theta squared. Okay, so where we place the square is important. Now, we actually get 2 more identities for free. If I take this identity and I divide by everything by sine squared theta, what I'm going to get is 1 plus cos squared theta over sine squared theta equals 1 over sine squared theta. And what this actually is 1 plus cotan squared theta equals cosecant squared theta. So I get this identity. Now I could also take this identity and divide by cosine, not cosecant, cosine squared theta, and then I would have sine squared theta over cos squared theta plus 1 equals 1 over cos squared theta, and what that is tan squared theta plus 1 equals secant squared theta. So I actually get these other 2 for free by just dividing by either sine or cos squared. Okay, so this one is very important. Okay, now let's just compute some special values. Okay, so if we think, I like to think of the trig functions in terms of the unit circle, okay, so where they are. So I'm just going to draw a little picture on the side here. Okay, so there's my coordinates. Okay, and then I'm going to have my unit circle like that. Okay, so I have all these special points. So this is 1, 0. This is 0, -1. Okay, this one is -1, 0, and 0, 1. So we can compute all the sine and cos values for these sort of easy angles. Okay, so sine of 0, for instance. Okay, so 0 has initial side and terminal side equal to this. So remember, the sine is the y-coordinate and the cosine is the x-coordinate. Okay, so that means that sine of 0 is 0. Cos of 0 is 1. Okay, so this is the y value at the point 0, 1. Okay, at that special point. And here we have the x value at the point 0, 1, because that's where the, oh shoot, sorry, this point is actually not 0, 1, it's 1, 0. I put it backwards on you. Okay, so those ones are easy for the 0. Now tan, you can always do as sine over cos, so it's going to be 0 over 1 or just 0. Another way to think of tan, though, which is actually kind of neat, is if you do a vertical line, okay, at x equals 1, it turns out, I'm going to draw you an angle here, do it in pink. So if this is my angle, okay, it turns out that this height, so where it intersects this point, this height, this is actually tan theta, okay, for that theta. So it makes sense for the angle 0 because it intersects at this point, okay, that it's the height, it's the y value, so it's 0. Okay, let's try some more. So if I'm at pi by 2, okay, this is 90 degrees. So that means that I'm at this my initial side, oops, and here's my terminal side. So this is the point on the unit circle I'm going through. So now it's 0, 1. Okay, so that means that sine of pi by 2 is going to be 1, and cosine is going to be 0. Okay, so this time we're using 0.01, because that one is on the terminal side here. So then a tangent, again, you could do sine over cos, so 1 over 0. This does not exist. Okay, you can't divide by 0. Another way to convince yourself it doesn't exist is using this sort of one I just showed you. So if this is its terminal side, okay, if it keeps going, it's parallel to this line. So it never intersects, so there is no height like that. Okay, pi is 180 degrees. Okay, so sine of pi, so 180 on this diagram, this is my initial side, this is my terminal side. So now I'm using this point here. Okay, so our point is -1, 0, and sine is the y value, so it's 0. Okay, so that means cosine is -1 here. So tan is 0 over -1, so 0. And again, our terminal side goes like this. So if you're going away from the line, you just continue it in the other way, okay? And that also gives you your tan value of 0. Okay, 3 pi by 2. So this is 270 degrees. Okay, so in our picture, we have this is our initial side and this is our terminal side, and our angle goes like that. Okay, so now we're looking at this point, 0, -1. Okay, so sine is the y value, so this is -1. The cosine is 0, and again, the tan value does not exist because I'm going to be dividing by the cosine 0 value. Okay, now 2 pi is a full turn. Okay, so we start here, we go all the way around, and then we end up in the same spot. So again, we're using the 0.10. So it's the same as the 0 angle. Oops. So it's 1, 0. So again, our sine is going to be 0. Cosine value is 1. Tan value is 0. Okay, so those are some really special ones. They're only 0s, 1s, or -1s, or does not exist. Okay, these should be almost second nature to you. And they come directly if you think about the sort of corner points of the unit circle. Okay, so all these angles intersect on the x or y axes. Okay, so those are some very special ones.